This is the impact test machine. Here we're going to prove how many energy can this sample can absorb. This is the sample. As you can see, there's an ASTM measurement, special measurement for every type of elements or composites. So we have this little piece. It has a specific width and a specific length. And we have two kinds of these ones. We have them at room temperature and at minus 16 degrees because they were in the cooler. Then we place the piece in here right at the middle, and then we have to take out the safety latch. This pendulum weighs about 7 kilograms, 7 to 8 kilograms. So this is the safety latch. And release.
For this type of test, it's really important to know that the machine that we're going to use is calibrated, because this is going to prevent that we have some percentage of error that we don't need to have if we calibrate in a prepared way the machine. For example, in this pendulum, we can know if it is calibrated if without some materials it goes to the 0 foot-pounds. For example, here we're going to release the pendulum. For example, here we know that in this time we have not calibrated correctly the machine.
Dale. Uy.
Impact resistance is the ability of a material to resist a high force in a short period of time. For example, in this lab session, we used the machine that I presented a few minutes ago, where it measured the impact resistance of any materials by applying the force of the machine of the pendulum and making the material to crack.
For impact test, we use different types of tests. For example, in this practice, we use the Sharp test, the one that is used for the steels or aluminiums of that type of materials. An easy way to know what type of test it is, for example, we're going to analyze the indentator. The indentator is really thin in comparison to other type of material, type of indentators, and it's very important to know that the material that we're going to analyze need to be in an horizontal position. A difference, like for example the isotope, that it need to be in a vertical position.
The other type of test of resistance of materials that we have is the ISO test, that consists in a much wider indentator, and the force goes up to this point, causing as much stress in the middle part of the sample.
A ductile fracture is when you know that it's a ductile fracture when the sample that was broken, it looks like kind of steep on the place where it was broken. That means that the material tried to get the most strain before breaking, and as opposed to a brittle fracture, if you look at a material with a brittle broken failure, it will look very flat. That means that the material tried to resist the most stress before breaking. One factor that can influence on this type of fracture is the temperature. For example, at a higher temperature, materials are more likely to have a ductile fracture, and on a lower temperature, they are more likely to have a brittle fracture.
What is a brittle ductile transition temperature of materials? Is the temperature in which the material stops behaving as a brittle one and starts to be a ductile one, or in reverse, a material stops being a ductile and starts to be a brittle one.
For the industry applications of the impact test, we can mostly say that it is mainly used for forging and for difference between carbon steel compositions and for the different percentages, and Also, it can be used to determine the ductility you want in a material, maybe while building a bridge or while building an aluminum top for a car. It can also be used for both rubber and plastics because they too have a breaking point and they are brittle depending on the temperature and the composite, and you also want them to be ductile. So it is mainly used for those things: forging, steel, aluminum molding, plastic and rubber ductility.
So this is half of our results. As we can see, we have the 1018 steel and the 1045 steel in the same measurements, and we can see that the energy absorbed varied from 47.5 foot-pound to 23 foot-pound, and the type of fracture in the case of the 1018 steel was ductile and the 1045 was brittle. It all changed when we varied the temperature from minus 18 degrees. We could see that the 1018 steel that was ductile turned into a brittle fracture after the impact.
This impact test is one of the most useful in the industry nowadays. Why? Because, for example, in the disaster of the Titanic 100 years ago, this could have been prevented. Why? Because after this practice, we understood that the temperature is a great factor that affects directly into the energy absorption of the material. So also in the mechanical industry, just as the manufacturing of cars and the security processes and tests, they can prevent a huge disaster. Because, why? Because, for example, a car will work different in a desert or in a cold place. And they have to prove all these materials in different places, such as we only make the difference with the temperature, but there's also a huge difference when there's humidity, when there's an arid area, and all that stuff that also affects. For this impact, we only test the temperature, but I think it's the most useful.
This practice for me is one of the most useful in the industry and mechanics because it's an impact test. In this practice, we use two different temperatures for the readings of the energy that the material absorbs. I think it's very important to know this type of test, so when we search for a material for a different prototype, we need to know at which temperature it's going to be working, because from example, in one of the materials, it depends if it was at room temperature or low temperature, the resistance, or if the material goes like a ductile one or like a fragile one.
Well, in this practice, we will able to reinforce our knowledge from class that certain materials change their mechanical properties according to the temperature they're at. So, in our testing, the most brittle one was the coldest, and the more ductile was room temperature.
So this was a different test for materials that we did on this practice. First of all, because on most tests that we did to test the materials, we got results on units of pressure, and on this one it was in units of energy. And what is that used for? So we can know how much a material can resist before breaking, and we as engineers can use that so we can design cars or machines or something else under some safety specifications and get the right design for all the materials and machines we want to build.
One thing that I learned that was really interesting for me is that besides the temperature, the one important thing that is important for the type of material is how much carbon does the material has, because it will determine how ductile or brittle will be the material. Knowing that if there is a lot of carbon inside the material will be less ductile.
Well, while doing the impact test practice, we found out that, I found out that the temperature has a bigger impact than what I expected. So yeah, it was really fun to see the difference between room temperature metal and different metal that has been for colder temperatures for a longer time. So yes, that is really fun and really cool, and it is also important to know it, because when building something that uses a steel carbon composition, we have to take into account the temperatures where it will be either ductile or brittle. So yeah, it was a really quick practice, but I learned a lot from it.